Hi, Assalamualaikum and a very good morning to my fellow friends and Dr. Norfariza. Today I would like to present assignment 2, which is this assignment is conducted by 2 person. My name is Farzana Binti Roslan, B0717100028, and my partner is Mas Aidillily Binti Muhammad Muzabir, B0717100150. We are from 4 Bmmd to 1. For this assignment 2, the component that we choose is the shock absorber. As we can see, there have many types of shock absorber in different cars. So for the shock absorber is the hydraulic pumps device that help regulate the springs and suspension of vehicles' impact and rebound movement. The main task of the shock absorber is to ensure that the tires of the car stay in contact with the ground surface at all the time. Along with smoothing out bumps and vibrations, it also provides the safest control and braking response from the vehicles itself.
Okay, I'm going to explain about the benefit of shock absorber. First is a safety. Safety is to provide steering stability and complete bicycle safety. The shock absorber also do not veer to the side when it's windy and have no trouble stopping. Second one is a stability. In stability, boosts the friction between the car tires and enabling car stability on the road. When paved roads have subtle flaws that apply force to the wind, causing it to move up and down. Third is comfort. Comfort is apart from providing bicycle stability, is to ensure the comfort of all passengers. They reduce the magnitude of vibratory motions due to various road imperfections to provide a smooth and comfortable ride.
There have 10 manufacturing processes that involve in making of shock absorber. The first one is raw material from warehouse. Then after that, it goes to process cutting the tube, and then after finish cutting tube, it goes to welding process. After finish welding process, it goes to cleaning process. The fifth process is the assembly, where the spring and nut are put together with the shock absorber. The sixth one is the testing, material testing to find the hardness of the shock absorber. The seventh one is sealing. 8 is gas injection. The ninth process is painting, and the last one is packaging.
For the mass properties of shock absorber, users show the assembly of the shock absorber. It consists of 4 components, which is a top rod, nut, spring, and base. So the mass is around 100.89 grams.
Next is the simulation test done by me, Farah. There are 3 types of simulation that I've been test to component nut, which is static, fatigue, and thermal test. The first simulation I use is static test. The material I use is the alloy steel, and the geometry is fixed at the outer of the nut, as we can see the green arrow there, and the external load I apply at the inner thread, which is in the pink arrow. The force I use to this static test is 2000 Newton, and mesh is fine. The results show the maximum force that can received by the nut is 3.712 Newton per meter square. The second simulation is the fatigue test. This simulation, the interpolate is by log to log, and it is derived from material elastic modulus, which is based on ASME austenistic steel curve. As we can see, the damage percentage is 2000 Newton per meter square. The last simulation test I done is the thermal test. The material I use for this simulation is the cast carbon steel. The contact sets I set to the inner track. The thermal load I use at the upper body of nut, which is the red arrow there, and the temperature I set to 350 Celsius. The mesh I use is fine. So based on the result, the maximum thermal test for this component nut is the 3.504 Celsius.
The component that I choose to run the simulation is base, and I select the material is a steel alloy. So this shows the mass properties of the base. Okay, the first simulation I used to run is a static test. So, as you know that I choose the alloy steel for the material, and this is show the green arrow. I select for the geometry fix, and the external load for the force I put is 1000 Newton. And this is the result for the stress point for misses, and the maximum number is 2.414 Newton per meter square. Okay, this is a result for the displacement and strain. The displacement is show the maximum number is 8.787, and for the strain is around 8.102. The second simulation I use is a fatigue test. So as we know that fatigue test is a finite element analysis. Start with a structural simulation to calculate the stresses and strains in the model due to a single load. So then I need to combine this result material model and descriptions of the repetitive loading that the production is expected to undergo during its use. So you can see that damage percentage is 1.001, and I choose the cast alloy steel for the material. Okay, the material properties. In the material properties, I choose the cast alloy steel. Model type in the linear elastic isotropic. And you see that the SN curve, so SN curve stands for stress, and that means the repetitive load, and stands for the number of cycles to failure. And for the source interpolate, choose in the log, and they're derived from material elastic modeling in based on ASME carbon steel curve. That's all from us. Thank you.